Hi students, once again I welcome you all to my channel, Abrar Sir Classes. Today we'll be seeing problems on the topic motion of conductor in magnetic field. Okay, this is in the chapter Electromagnetic Induction. We'll see the very first problem. What it is saying, figure shows a square loop of side. How much you have given? 5 centimeter. Being moved towards right at a constant speed of, they have given the speed. Okay, they have given the length. Length is how much? 5 centimeter. That is 5 into 10 to the minus 2. Okay, meter. That is length of the what? Square. Okay, side. The front edge enters the 20 centimeter wide magnetic field. 20 centimeter wide magnetic field at t is equal to 0. Find the EMF induced in the loop at t is equal to second. What is the formula for EMF induced? They have given V also, they have given V is equal to how much? 1 centimeter per second. Okay. And they have given what? B they have given. B is how much? 0.6 Tesla. 0.6 Tesla. What is the formula for calculation of EMF induced? EMF induced is equal to BL into V. Now, at t is equal to 2 seconds, we know that what is speed is equal to distance by time. Speed is equal to distance by time. Understood? How much is the distance? It is entering distance is equal to speed into time. Speed into time. How much is speed? That is 1 into 2 seconds at t is equal to 2. Okay. Distance is equal to how much? This will be how much? 2 centimeters. In the first case, it is entering 2 centimeters into the magnetic field. Understood? Now, how much is E? E is equal to B is how much? 0.6 into length of the square is 5 into 10 to the minus 2. How much is V? V is 1 into 10 to the minus 2. Right. Okay, that is equal to 1 into 10 to the minus 2 meters per second. That is equal to how much? 0.6 into 5 is 3 into 10 to the minus 4. This is the EMF induced in the very first case. At t is equal to what? 2 seconds. When in the second case, okay, this is at t is equal to 2 seconds. Okay. Now at t is equal to d, at t is equal to how many seconds? We have to calculate 10 seconds. That is equal to s into t. Speed is how much? That is 1 into 10 is 10 centimeter. Now when this enters 10 centimeter inside, means to say in the very first case it is entering just how much is this? This is 2 centimeter in the very first case. Okay, this is how much it will be. It should be 3 centimeter. At t is equal to what? 2 seconds. At t is equal to 10 seconds, it is entering 5 centimeter. Entering 5 centimeters means distance. Already it is outside how many centimeters? Already it was, okay, it is 5 centimeters. Hope you understood. Okay, if it is completely inside the magnetic field, what is the flux? The flux is constant. EMF induced will be 0. E is equal to 0. Okay, volts. E is equal to 0 volts is the right answer. In the first case, E is equal to 0. 3 into 10 to the minus 4 volts. It is the option. Yes. Both the options are in volts. Okay, because since there is no EMF induced because the flux is constant here. Hope you understood this sum. This is at t is equal to 10 seconds. We will see the next problem. What it is saying? Two long parallel metallic wires with resistance R from a horizontal plane. Okay, a conducting two long parallel metallic wires with resistance R from a horizontal plane. Okay, now a conducting rod AB is on the wires shown in figure. The space has magnetic field pointing vertically downwards. Okay, the rod is given an initial velocity V0. There is no friction in the wire and the rod. After a time t, the velocity V. Okay, you have been given what? This V0 is what? Initial velocity. V0 is what? Initial velocity. If you have been given initial velocity, what will V is equal to? V is equal to V0 e to the power of minus t by 2. It will be decreasing exponentially. If this is V, this is t, okay, the graph will be like this, exponentially decreasing. But what is tau? Tau is what? Time constant. Time constant. And that is given by m into r divided by b square, the value of m into r divided by b square into l square. B square into l square, time constant. Okay, now from here, from this equation we came to know that v will be always what? Less than v0. It is exponentially. V is less than v0 is the right answer. Hope you have understood this one. We'll go to the next problem. What is saying? As shown in the figure, a metal rod makes constant and complete contact and complete the circuit. The circuit is perpendicular to magnetic field with B is equal to 7. The resistance they have given, B they have given 0.15 Tesla. If the resistance R 3 ohm, force needed to move the rod as indicated with a constant speed, V is equal to how much? 2 meter per second. And that is equal to constant. We know that if it is constant, this force and this Amperian force will be equal, because this is called the terminal velocity, terminal speed. At that time acceleration is 0. Okay, both the forces are equal at that time. F will be equal to what? F will be equal to F Amperian. F will be equal to what? F Amperian. Now that is nothing but what? F is equal to, what is the formula for F Amperian? B square L square V by R. So that F is equal to how much is B? They have given 0.15 into 0.15. How much is the length of this conductor? They have given L is equal to how much? L they have given as 50 centimeter. 50 centimeter means 50 into 10 to the minus 2 meter I can write. Right? 50 into 50 into 10 to the minus 4. Okay. Into V is how much? 2 divided by R is how much? R is 3. Right. Okay. That is equal to, now we can just 0.05 divide this one. Okay, so I can write this as 5 into 15 10 to the minus 2, 10 to the minus 2, 10 to the minus 4 to become. Okay, into 5 into 5, 25 into 10 to the power of 2 I can write, into 2 into 10 to the minus 4. Alright, that is equal to 25 into 2, 50. 50 into 5 minus 8, that is equal to, how much is 250 into 15? 3750 So that is same as what? F is equal to 3.75 into 10 minus 3 newtons. Hope you have understood. This is the right answer. Next problem is C. A wire CD of length L, okay, they are given, and mass M, length L and mass M, is sliding without friction on conducting rails AX and BY. The vertical rails are connected to each other with a resistance R between A and B. Okay. A uniform magnetic field B is applied perpendicular to plane. Okay. ABCD such that CD moves with a constant velocity. It is moving with a what? Constant velocity. It is moving with a constant velocity. That is the maximum velocity, or that is the terminal velocity, when this force is equal to what? Amperian force. Is equal to what? Amperian force. Understood. Now, how much is this force? This force is mg. Okay, this force is mg, and we know that V ampere is equal to F. V ampere is how much? V ampere is nothing but P square L square V by R. This mg. Okay, from here you simplify for V is equal to mg R divided by P square L square. The right answer. V is equal to mgr divided by P square by L square, which are, hope you understood this. At that time, acceleration is 0, velocity is maximum, that is called terminal velocity. These two forces are equal. This is the Amperian force and this is the force, okay, that is exerting on the rod. Next problem we will see. What is this? This looks a very big problem, but this is very easy, okay. First, as soon as you see this sum, okay, you have to calculate the direction of the current. Direction of the current they have given. Therefore, see, you have to use your right hand palm rule. Okay, this is field is inside, fingers will be inside, right side, because it is moving on the right side, and you'll be getting what? Positive pole on the palm. Palm is towards positive pole. This is E. Okay, this is E. Okay, this current is with a constant velocity. It is because it is moving with a constant velocity. Field is inside, fingers will be inside. Okay, fingers will be inside, and thumb points towards the velocity. Okay, and the palm points towards upwards. Palm is, this is positive pole and this is negative pole. Okay, now a square metal wire loop of side they have given the side. Okay, and resistance R. Length they have given. Length is how much? 10 centimeter. And then they have given that is 10 into 10 to minus 2 I can write. Okay, and they have given resistance, and resistance 1 ohm is moved with a constant velocity. Okay, resistance 1 ohm is, our resistance is how much? 1 ohm. Okay, resistance is 1 ohm. Is moved with a constant velocity. V naught, uniform magnetic field. They have given magnetic field P is equal to how much? 2 webers per meter square. Okay, as shown, the magnetic field lines are perpendicular to the plane of the loop. Okay, the loop is connected to a network of resistors, each of value 3 ohms. Okay, here they are connected. The resistance of the lead wires OS and OP are negligible. Okay, OS and OP are negligible. All right. OS and PQ are negligible. What should be the speed of the loop so as to have a steady current of 1 milliamperes in the loop? Okay. Now, here see, if I write the equivalent circuit for this one, okay, this is plus and this is minus, this is E, and what is this resistance is 1 ohm. Okay, I have written this as what R is equal to 1 ohm here. Understood? Now if I observe this one, this is a balanced Wheatstone bridge. Okay, 3 by 3, 3 by 3. This gets cancelled. 3 plus 3 will be what? 6. 6 in parallel with 6 will be 3 ohm. This is 3 ohm. Understood? Now, let me call this is what? R dash. R dash is equal to how much? 3 ohm. This is the current I. What is I is equal to? What is I is equal to? E by R. E by R plus of R dash. That is equal to E by how much? R plus R dash is 1 plus 3 is 4. E by 4. Therefore, E will be equal to what? E is equal to 4 into I. And what is E also? E is nothing but what? E is equal to B into L into V. B L V, and that is equal to 4 I. I can write. What you have to calculate? You have to calculate the value of the V from here. Okay, I can simplify for V. V will be equal to what? V will be equal to 4I by V into L. V is equal to 4I is how much they have given? 1 milliampere. 1 milliampere. Okay, divided by B is how much they have given? 2. And what is the length they have given? Length they have given is 10 into 10 centimeter. That is 10 into 10 to the minus 2. So V will be equal to this 2 times, okay, 2 into 10 to the power of minus 3, and then minus 1, minus 1 plus 2. That is equal to V is equal to 2 into 10 to the power of minus 4 plus 2. That is equal to P is equal to 0.02 meters per second is the answer. 0.02. Hope you understood this one. Next problem we'll see what they are asking. A conducting rod PQ, okay, of length L, okay, they have given conductor length L is given. L is equal to how much? 1 meter they have given. 1 meter. Moving with uniform speed V is equal to how much? 2 meters per second they have given. B they have given. Magnetic field 4 Tesla direct into plane of the paper. The capacitor of capacity C is equal to how much? 10 microfarad they have given. It's cannot action. Then, okay, right hand palm rule. Okay, we are very clear with this is the velocity. Okay, this is the magnetic field. Okay, this is positive pole, positive, right. Okay, now here fingers inside, thumb right side. Okay, palm is upwards. This is plus and this is minus. If this is plus and this is minus, this will be plus Q and this will be minus Q here. Okay, what is the charge? Charge is given by Q is equal to C into E. And what is C? What is C they have given? How much is E? P L V. Okay, that is equal to C is how much? 10 into 10 to the power of minus 6. Okay, that is 10 into 10 to the power of minus 6 farad. Into B is how much? 4 into L is how much? 1 meter. V is how much? 2. 4 2s are 8. Okay, 8 into 10 is 80. Okay, 80 10 to the minus 6 farad. That is Q is equal to 80 microfarad. Therefore, QA will be what? Plus 80 microfarad, Q will be minus 80 microfarad. This is wrong. This is wrong. Charge stored in the capacitor increases exponentially. No. Here, since C is constant, V is constant, L is constant, and V is also constant, uniform field, charge cannot increase exponentially with time. Okay. Hope you understood this. All the problems. Kindly, if you like the video, like it, share with your friends, subscribe for my channel, and ask doubts in the comment box. Thank you one and all for KCET and NEET 2026 aspirants.